Okay, in this video we're going to take a look at another application of induction to do sort of a more of a puzzle-like problem. We want to show that we can make any amount of postage 12 cents or more using just 3 and 7 cent stamps. This is sort of a typical example. There's lots of different variations. We could change the stamp denominations and things like that. But before we actually get into the real proof, I just wanted to explore a little bit. So let's start with trying to make 12 cents of stamps, right? We have 3 cents and 7 cent stamps. And you can sort of just play around with this for a little while and come up with how you would make 12 cents, right? But I think we can see if we do 3, 3, 3, and 3, right? 4 threes will make 12. Okay. Once you do this a few times, you might sort of figure out what the strategy is, and then you could make the case for how you would prove that this could be done for any amount of stamps. Okay. Now for 13 cents, right? Let's think about what we would do. Okay, we can't. 13 isn't a multiple of 3. It's not a multiple of 7. It's somewhere in between. So we could start with 1 7 and 1 3, and then figure out what we have. Right? Another 3 will take care of it. Okay. Now ultimately we want to try to figure out what we could do to go one higher each time. Right? Think about how we could go from 12 to 13, how we can go from 13 to 14, and come up with an actual strategy that we could then predict and prove. Okay. But right now we're just doing this by exploration, and then we'll come back and take a look at it. Right? 14 is really just 7 and 7. 15 is back to all threes. Right. And maybe we'll just do one more to kind of look at it and see what we have. 16 cents. We could start with a 7 and a 3. Right, that's 10. And if we do 2 more threes, right, we'll make 16 cents. Okay, that's supposed to be a cent sign. Okay, so if we try to go back and sort of analyze what happened here, when we went from 12 to 13, you could see we still had 2 threes here. Right? But if you notice, these 2 threes, right, got turned into a 7. And that sort of makes sense. If you replace 2 threes with a 7, right, what used to be 6 is now 7, you've gone up by exactly 1 cent. Okay? And over here in this next example, if you notice, we take these 2 threes and replace them with the 7. Right? So one way we could always go up by exactly 1 cent, which is what we're going to have to do for our induction proof, is to replace 2 threes with a 7. Go from 6 cents to 7 cents, and your total has gone up by exactly 1 cent. Okay? But now we have a new problem. What happens when we don't have any threes? Well, what did we do here? We replaced these 2 sevens with 5 threes. Right? Now 2 sevens is 14 cents, 5 threes is 15 cents. So again, we went up by 1 penny. Right? In this last example here, right, we had 2 threes. We could replace these 2 threes with a 7, right? And then the next time we could replace 2 threes with a 7. And then the next time after that, we would replace 2 sevens with 5 threes. Okay, so as we do this by exploration first, we can sort of see what our strategy is. But then we have to prove it using induction. And we're going to prove this using induction, and then we're going to prove it using strong induction, which is sort of a more formal technique. Strong induction, regular induction, let's take a step back, says that you can always get the next value by using the previous value. Right? And along with the basis step, that sort of creates this domino effect. 1 implies 2, 2 implies 3, 3 implies 4, and so on all the way through forever. What strong induction does is it allows us not just to use the previous step, but any previous step before. Okay? The proof is a little cleaner, but it's a little bit more complicated. It's more powerful, but it's a little bit more complicated. Okay, so we're going to start this off just using regular induction, and really, you know, for this level, that's probably fine. But I'm going to show you the strong induction just so you have some exposure to it. Probably more for the math majors at this point. You might see something like this. And there's some nice other examples, but I would only stick to the postage examples this semester. Okay, so the basic step is we're going to have to show that 12 cents is possible, right? And we know that that's possible using 4 3-cent stamps. Okay, so remember the basis step shows that we have to is always to show that we can start this process, right? And then beyond that, we have to do the inductive step, which shows that if it works for k, it's going to work for k plus 1. Okay, now I'm going to type this out just because I think my handwriting is going to be a little bit of a problem for you to read. Let me just try to get the font right. Okay, so the inductive step is going to be the following. Okay, we're going to assume that postage of k cents, right, can be made using only 3-cent and 4-cent, 7-cent stamps. Okay. Okay. Then what we're going to have to do is show that a postage, sorry, my typos, it's still probably easier than reading my handwriting, that a postage of k plus 1 cents can be made. All right, so using 3-cent and 7-cent stamps only. Okay. All right, so remember, with induction proofs, we're always assuming that something works for k, and we're trying to show it works for k plus 1. Okay, so with regular induction, we have to sort of do a little bit more of that exploration that we just did in the previous page, where we figured out, okay, what are the cases that we could use to go up by exactly 1 cent? The strong induction will be a little bit cleaner, but this is certainly enough and effective, and I think it kind of illustrates the main points. Okay, so there are really two cases here. Right, and let me just go back 1 second so we could see how we did this. Right, so one case is if you have two 3-cent stamps, you can just replace them with a 7. Right, the other case is if you had two 7-cent stamps. Okay, now eventually we'll have to argue that one of these two has to happen. Right, but this is always set up in such a way that that works. Okay, so the two cases. One case is you have at least two 3-cent stamps. Okay, maybe I should spell this out just so it doesn't look like 23 3-cent stamps. The other case is that you have at least two 7-cent stamps. Okay, and I'll just put an extra space here so this doesn't look like 27 and this doesn't look like 23. Okay. Now, before we go any further, we should sort of believe, or at least think about whether or not this is true, right? And you know that once you get above 12, right, you're going to have either two 3-cent stamps or two 7-cent stamps, right? If you only had one 7 and one 3, we could sort of argue this by contradiction. If you didn't have at least two 3-cent stamps, or you didn't have at least two 7-cent stamps, then you could have at most one 7-cent or at most one 3-cent stamp. And if you had at most one 7 and at most one 3, right, then you'd be stuck at 10. Okay, so we would never give you one that couldn't be done. This assumption may take a little bit. Someone could come and question, well, why do you know you have this? Then you'd have to be able to explain that. Usually a proof by contradiction would be enough there. Okay, so this is where we are right now. Right, so I think we have enough reason to believe that any future postage of k cents, right, is going to have at least two 3-cent stamps or at least two 7-cent stamps. So the idea is if you have at least two 7-cent stamps, right, then you're going to replace the two 3-cent stamps by a 7-cent stamp. Right. I'll just try to make this stand out. I'm doing a little editing on the fly. Okay, I don't have my regular school computer in front of me, so that's the best we can do. Okay, so at least two 3-cent stamps here, right? Then you just replace the two 3-cent stamps by a 7-cent stamp, and now k went to k plus 1, right? Now for this one over here, if you have at least two 7-cent stamps, right, then we're going to replace this, right? We're going to replace the two 7-cent stamps by 5 3-cent stamps, right? So we're going to go from 14 to 15, right? Which means, again, you're going from k to k plus 1. I probably don't want too many arrows there. Okay. So at this point, in a little bit less formal than our regular induction proofs, we've kind of shown here everything we need to. We assume that we can get to 12 cents. We've established that anything above 12 cents is going to have either 2 3s or 2 7-cent stamps, and we've explained a strategy what to do, and therefore we can always get from k to k plus 1, and therefore this proof is complete. Okay, so this would be a fine proof by induction. It's a little bit more verbal than algebraic, and a little less formal. Okay, the idea with strong induction is that we would use all the previous values to get that, to show that the proof works. So it's a little bit more direct. Okay, so we'll try that here on the next page. Okay, so to do a basis by strong, this proof by strong induction, our basis step is going to look a little bit different. We're going to have to show that we can do it for 12 cents, that we can do it for 13 cents, and we can do it for 14 cents. So we're going to have multiple base cases. Right? We know that 12 is 3, 3, 3, 3. We know that 13 is 7, 3, and 3. These are all 3s. They're a little bit hard to see just because of my lack of good pen. Let me clean this up. And maybe I'll just resort to typing if I can't do any better here. 3, 3, 3, 3. 7, 3, 3, and 14 we know we can do with 7 and 7. Okay, so that's the basis step, and we're going to introduce this sort of notation to make it a little cleaner, that P of K means you can make K cents, right? So we could say here that we really have P of 12 is done, right? P of 13 is done, and P of 14 is done, right? So that's our basis step. Okay. Now our inductive step is going to be a little bit different. Okay. Okay. We're going to start with our inductive hypothesis, right? Which we're going to try to show in order to make P of k plus 1 true for any k which will be greater than or equal to 14, right? Because we've already covered 12, 13, and 14 in the basis step. Okay. All right. We're going to do this using P of k minus 2. Okay, so I'll explain that in a minute. Right? But the basic idea here, and this is where it gets a little bit more complicated, but it's also a little bit more formal, is we want to show that P of j works for any, we're going to assume actually, let's try that again. We're going to assume that P of j works for anything between 12 and k. So the major difference between regular induction and strong induction is, with regular induction you always start with k and go to k plus 1. With strong induction you can use anything before k to get to k plus 1. So in this case we're actually going to go back 2 from where we need to be, add a 3-cent stamp, and now we'll be exactly where we want to be. Okay, so this is a slightly different strategy. It's a little bit more formal. Okay, but it doesn't take all that sort of trial and error of thinking about how we get from one point to another. Okay, so we're going to assume that P of j works for any j between 12 and k, and now we're going to have to show that P of k plus 1 works. Okay, so how do we get to k plus 1? Well, we're going to take P of k minus 2 works, right? Because if k is greater than or equal to 14, right, then we know that k minus 2 is in fact greater than or equal to 12, right, which means P of k minus 2 should work, right? Anything before k should work. P of k minus 2 exists as long as we're above 14, or at least 14, right? So we're safe here, right? We're not getting into dangerous territory where we don't know if P of k works, okay? If you take whatever postage it takes to get P of 2 and then add a 3-cent stamp, right, then you have P of k plus 1, right? Because if you go down 2 and add 3, now you're at k plus 1. Okay, so this is not complete. The book has sort of a full rundown of the all the steps involved in strong induction. Okay, but what makes this different from the regular induction is we didn't just use k to use k plus 1. We actually went from k minus 2 to get to k plus 1. Okay, so because we're going back in time more than just one element, right, we have to have more elements in our base case. And the key here really is that once we get above 14, that's why we had to go all the way up to 14 in our basis step. Once we get above 14, we can go down by 2 and still be covered by valid postage amounts. Once we go down by 2, we can add a 3-cent stamp and get up to k plus 1. So the language is a little bit cleaner here. The process is a little bit cleaner here. But it's also a little bit more complicated with all these J's and K's, and it looks a little bit harder to understand. I think at this level, what's sort of more interesting is to see if you can come up with a strategy. How can you go up by exactly 1 and figure out what the cases are? Okay, this is something that I like to do a little bit of, not too much of. I think you'd be better off sort of showing things this way here using this strategy than the full strong induction proof. But both of these are here for you to use. Okay, so give it a try, do the best you can. If you can at least show how to get up by 1 cent using some sort of combinations, and that's probably good enough for now. You don't have to be too formal with the language.